Yeah, today we're going to be looking at electricity calculations. We're going to be looking at what? Electricity calculations. In your JAM and in your WAEC, you are supposed to do calculations on resistance, EMF, voltage, you understand? All those calculations you're supposed to do it. So we're going to be taking some examples, one or two or three examples, to get you in tune to what you are required to do. So you can have such question in Jambas. A cell having an EMF of 1.5 volts and an internal resistance of 2.0 ohms is connected in series with an ammeter of resistance 0.3 ohm and a resistor of resistance 8 ohms. Determine the ammeter reading. When you are asked determine the ammeter reading, what are you asked? To measure the what? Current. The ammeter reading. All of us know that ammeter measures current. So when they tell you to determine the ammeter reading, they are simply telling you to calculate the what? Current. Then number 2, determine the potential difference across the terminals of the word cell. So when you're given a statement like this or a problem like this, first of all, try and understand the question. First of all, try and do what? Understand the question. So relate this question with the diagram that will be given to you. They are going to also give you this diagram. They are going to also do what? They are going to also give you the diagram. So try and understand the question you are asked in relation to the what? Diagram. So let's take the two of them together. A cell having EMF. This is the cell, is it not? The cell has EMF of what? 1.5. Can you see that? An internal resistance of what? 2 ohms, 2.0. There is a mistake here, but so I'm supposed to put 2.0 ohms. Can you see that? So this EMF of 1.5 volts and resistance of 2.0 ohms, they are the properties of this cell. They are the properties of what? This cell alone. You understand? So whenever you are representing the internal resistance of a cell, you use lowercase r. You use lowercase what? R. But when you are representing the normal resistance, you use what? Higher uppercase what? R. But here you see r. This r, and this r, all of them means resistance, is it not? But this small one means internal resistance of a what? Cell. But this one is the normal resistor resistance. Is that clear? So here, a cell having EMF of 1.5 volts and internal resistance of what? 2 ohms is connected in series. Is connected in what? Is connected in what? Series. To an ammeter of resistance what? 0.3 ohm. Can you see that ammeter? In series to an ammeter of 0.3 ohms and a resistor of resistance what? 8 ohms. Can you see? All of them are in series. All of them are in what? Series. Now they are asking you now, determine the ammeter reading. That is, calculate the current that is passing through this ammeter. Can you see the ammeter? Yes. Determine the ammeter reading. So how do you go about this? You use the Lorentz-Volts relation. Yes. Can you remember the Lorentz-Volts relation? It's in your notes. Good. Difference between the potential difference when it is only the what? Cell and when resistors are what? Connected. That's Lorentz-Volts relation, is it not? So when you now put this, make EMF of the cell the subject, you're going to get that E is equal to what? IR, which is what? The voltage of the whole circuit, plus what? I small r, which is the what? The voltage on the what? Cell alone. Is it not? So we have E equal to what? I in bracket. This thing, if you are writing it in full, what you should have had is what? E is equal to what? I big R plus what? I what? Small r. Is it not? Yes. You took I out of the bracket, that's why you saw this. And we know that this thing now can be equal to E, equal to I big R is what? V. Is it not? Yes. Then this other one is what? This other one is EMF. This other one is what? EMF. You understand? Can you understand this? So that this one now is equal to E minus what? V equal to this one. Is it not? which is the lost volts equation. Open your lost volts equation note. Let me see it. What did we say is lost volts? Lost volts. That is it. Lost volts. That is it. Who has it? Let me see it. That's the equation. You have it there? Good. That's the equation. It has. You didn't copy it, please. This is the lost volts equation I gave you the last time we had a class. Lost volts is equal to what? E minus what? V. Is it not? E minus V is equal to lost volts. Is it not? So check the last equation that we did. You will see this equation. So in essence, it comes to this. You understand? So now to get the ammeter reading, you say that you make what? Current the subject of the formula. You make what? Current the subject of the formula. So when you make current the subject of the formula here, you have what? I equal to what? E all over what? Big R plus what? Small r. Is that clear? So, for the effective resistance, you need to calculate the effective resistance, which is the resistance here plus the resistance what? Here. And they are connected in what? Series. So how do you calculate it? You simply add them together. So you have 8 plus what? 3. 8 plus what? 0.3, giving you what? 8.3. That is the effective resistance. So now current now is equal to what? E. What is E? 1.5. All over what? The effective resistance R, which is what? 8.3 plus the internal resistance, which is what? 2.0. You understand? So that you have 1.5 all over 10.3, giving us what? 0.15 E. Is that clear? So that is the ammeter reading. So we've solved the number 1, is it not? Now to solve number 2, which is what? Potential difference across the terminals of the what? Cell. What is the potential difference? Total potential difference in the what? External circuit. You know that this cell is supplying the external circuit. You understand? So the potential difference across the terminal of this cell is the total what? Potential difference in the external circuit, which is simply IR. You understand? Which is simply what? IR. That is what? Current times what? Resistance. We know that potential difference V is equal to what? IR. Is it not Ohm's law? So potential difference is equal to I all over what? Effective resistance, which is R1 plus what? R2, which is equal to 0.15, which is the value of the current we got, times what? 8 plus what? 0.3, giving us what? 1.2 volts. Is that clear? So check this out. This is how you make the calculation. This is how you do what? This is how you do the calculation. You are supposed to study the equations that I've given you already. All the equations that I've given you already, they are very, very important. When you get them down, you understand this more. Read the question very well. Look at the diagram. Relate the question with the diagram. Then check the equations from the ones I've given you. The best one, like I told you, this one, the best equation to use in solving for the ammeter reading is the what? Lost volts equation. Is the what? This is equal to what? Lost volts. E minus V equal to this. You understand? So if you write it in another way, you have this. Make I the subject of the formula. Calculate the what? Effective resistance. Solve for I. Then use the value of I, which is current that you've gotten, multiply it by the effective resistance of the external circuit to get the what? Voltage, which is what you are asked. Is that clear? Is that clear? Thank you.